All right, so graphs represent a picture to the solution to some equation. So if you remember when I first drew some lines on the first one to connect those points, that was a line, and the graph is the picture, that line, and that's a solution to some equation. Now, every point on the line is a solution to the equation, so it doesn't matter which point you pick on that line, it's a solution. And so what we can do is we can plot points by plugging in x values and solving for y to get solutions to an equation, or we can use a point and slope to obtain points. We're not going to do the second one yet. The first one is what we're going to start with. We're going to plot points. And so what we do is we say, okay, well, this is our equation. We're going to graph by plotting points. Now, we could draw it directly if we knew the point slope formula and how to draw that, but we're going to do plotting points first. And so I'm going to pick points for x. Well, let's pick some negatives, let's pick some positives, and I think also I'm going to pick a 0. So maybe we'll pick maybe a -1, 0, 1, 2. Just no reason at all, just because I picked those. All right, so -1. If I plug in -1 here, 3 times -1 is what? Well, that's a -3. Minus one more, that's a -4. Well, if I plug in 0, well, 3 times 0 is 0, and I just get -1. What if I plug in 1? Well, 3 times 1 is 3, minus 1 is 2. Plug in a 2. 3 times 2 is 6, minus 1 is 5. So now I could rewrite these as -1, -4, and then I have a 0, 1, and I have a 1, 2, and I have a 2, 5. So what I'm going to do is I'm going to plot all four of those points over here, and then I'm going to try to draw a line. Okay. So we have a -1, and then we have a -4. So it's down here somewhere. And then we have a 0, 1. It's going to be here. Then we have a 1, 2. And then we have a 2, 5. Okay. And that, let's see, 1, 2. Oh, it's 0, -1. I'm like, that doesn't work. That's a negative. I dropped my negative. It's like, that doesn't look like a very straight line. So when you get it and you don't get a straight line, you know you've done something wrong. And what I did was I dropped my negative when I wrote it down here. So now that looks more like a straight line. And now I'm going to butcher the straight looking line, and I'm going to try to draw points or draw a line through the points. All right. And so that is my line through those points. And then we'd kind of put an arrow kind of each direction, because all those points going that way and all of the points going down also are going to be solutions to the equation y equals 3x minus 1. And again, we only plotted for the points, but you could choose many, many, many other points. You could choose decimals, you could choose whatever, and you'd get an infinite number of points on that line. All right, so again, we're going to graph this equation by plotting points. And so again, we're going to choose 4 points only, and then we're going to plot. Well, to get this, what we really need to do is we need to solve for y. Because if you noticed, our last one was solve for y, and it was pretty easy. We plugged in a number, did a little math, and got an answer. Now this one, if we plugged in x for some number, then we're going to have to do some math here to get all this, and then divide, do all that. And you're going to have to do that for each and every point you choose. But if we say, okay, well, let's subtract 3x from both sides, we get -2y equals -3x plus 4. Now we could divide by -2 on all parts. And so that gives us y equals, that's going to be a positive 3/2 x, then minus 2. Okay. Now, what am I going to choose for points here? Well, I'm going to choose points because I have to plug in an x. So I wanted to make it so it's divisible by 2. So let's plug in, let's change it and do a -2. If I plug a 0 in, that'll work. If a -2 works, a +2 works. And let's make it a 4, okay? Just for choosing numbers. Again, it doesn't matter what numbers you choose, you're going to get a value out every time for y. So if we plug in a -2 here, that's going to give us a negative, and the 2's cancel. We'll get a -3 minus 2 is a -5. We plug in 0. 0 times anything is 0, minus 2, that's a minus 2. Now if we plug in a positive 2, those cancel, we get 3 minus 2, which is 1. And finally, if you plug in a 4, 2 goes into 4 twice. 2 times 3 is 6, minus 2 is 4. Okay. So do we really need to write out the points again? Well, we could, and hopefully we won't drop our negatives this time. 0, negative 2, 2, 1, and 4, 4. So those are the 4 points we chose, given, we picked out some x's that were easily divided by 2, and then we found the y's in after that. So let's plot the points. Negative 2, negative 5. So we have negative 2, negative 5. We got that point. 0, negative 2. 0, negative 2. We have that point. 2, 1. So we go over 2, up 1. We have that point. And then 4, 4. So we go over 4, up 4. We have that point. All right, now we have to try to draw a straight line again. And so, it's going to come down something like that. And again, all points on this line are going to be solutions to this equation. Okay. Now notice this is what we call our slope. And over here, we also had a positive slope and a positive 3. And positive slopes are going to go up like this. Now, if we had happened to have a negative slope is going to go down here. And we'll see that here in a little bit. But that's kind of something, while we have the graph up, this is how it's going up because of our positive slope. And this is what we come to here. So we have the slope of the line is m. That's what we call slope. Okay. And what is m? Well, m is the delta y over delta x. Well, what is delta, you ask? That is the change in y over the change in x. Well, a lot of times we've heard of that as the rise over the run, which we understand. That's pretty easy. And how do we find the rise of the run? Well, we take and find 2 points, and we say, well, y2 minus y1 divided by x2 minus x1, and that will give us the slope. And then we then have knowledge of if it's going to be m is greater than 0, it's a positive slope and a line rises from right to left. So positive slope is here, so m greater than 0. Now, if m is less than 0, it's a negative slope and the line falls from left to right. So then it goes down like this, and this is m is less than 0. So it goes down from left to right. Okay. Now, the key thing here also is, depending on where your line is, maybe you have a line that has a slope like this versus a line that has a slope like this. And I say, which one is the steeper slope? Well, the larger m is the steeper the line will be. So this will have a larger slope than this one. This will be a really gradual slope. This is a very steep slope. And so the larger the m, the steeper the line is going to be. Now there's two special cases for slopes. And the first one is m is equal to 0. Okay, and what we get is the horizontal line. So what we could do is we could pick out some numbers. We could say maybe pick out this one and this one because those are pretty easy to choose. Then what we have for points are here we have 0, 3, and here we have 3, 3. Now, if we use our nice formula here, what we can do is we can take the 3 minus 3, the y2 minus y1, and get 0. Then we take 3 minus 0, and we get 3. 0 divided by 3 is 0, and that shows that our horizontal line has 0 slope. Now, the other case is a vertical line. A vertical line is undefined. So there's basically, we can't tell what the slope is. It's undefined because what happens is we divide by 0. Well, how did that happen? Well, what we can do is maybe we can say again, I don't know, let's choose 2 and 0. Okay, so we have our point 2, 2, and we have our point, let's see, 0, 2. Oh, 2, 0, sorry. I wrote that one wrong. 2, 0. All right, and so what we're going to do is we're going to take our change in y. 2 minus 0 is 2. 2 minus 2 is 0, and we can't divide by 0, and hence it's undefined. Okay, so doing this little bit here, we used some of our math skills using, the slope formula, and we were able to distinguish, the 2 divided by 0 versus the, 0 divided by 3 in this case. Okay, so horizontal line gives us 0 slope, a vertical line gives us undefined slope. So let's do a little bit more with those. So we're supposed to find the slope from the graph. So kind of two different formats how graphs might look in your homework. So the first one, we need to find the 2 points. So we have -1, 2. Here we have 1, 1. And so slope is going to be, again, our delta y over delta x. And so if we take 2 minus 1, we get 1 for y, change in y. Here we have -1 minus 1 is going to be a -2. And so our slope is a -1/2. Well, -1/2 should be going down. Well, that's what it's doing. It's going down from left to right. So that looks like we probably did that problem right. Okay. Now, what is the rise? Well, the rise is this part. That's 1. The run is that part, well, actually a -1 because we're going down. And the run is 2, so it's a -1 over 2, and that's what we get there. So we could have done the rise over the run, we could have done, the delta over the delta, or however we want to do it. It doesn't matter as long as we get the right slope. All right, so here we're supposed to find the slope here. So again, maybe we choose 2 points. I don't know, that looks like 1 point. That looks like another point. And I'm choosing points that are nice and easy. So I could have chosen, that one, maybe that one, maybe that one. So again, let's do it by points and what they say. So what's the first point? That's going to be 0 minus 2. And this is going to be 3, 0. So our slope, changing y. So a -2 minus 0 is a -2. 0 minus 3 is a -3. And so negative divided by negative is positive. So we get 2/3. We do have a positive slope, so that looks good. Now, what is our rise over run? Well, here, that's 2. Here, that's 3. Okay, so that does make sense for as our rise over run goes, or doing the points and doing the math that way. So both ways work. The key thing here is, like I did here, oh, that's a difference of 1, but I forgot the negative because we're going down. So that's one thing to mention. Here, we're going up, and so it's a +2. Okay? All right, so let's stop there, and we'll come back for more.